asking about the sulfate ion SO42 minus, and it says draw all 6 resonance structures. Before we can do that, we actually have to get one of the resonance structures. So here's my sulfate ion. I will go through the process. Each sulfur has 6 valence electrons. Each oxygen has 6 as well, and there are 4 of them. And then I have a 2 minus charge, which means add 2 electrons. When I add these up, I get 32 total electrons to put into my Lewis structure. And from there, sulfur must go in the center. It will be surrounded by all 4 oxygens. And so far, I've got 2, 4, 6, 8 valence electrons.
Excuse me, Prof. Why did we choose sulfur?
Good question. So on my periodic table, which I should have printed out, I'm sorry I did not, sulfur is less electronegative than oxygen.
Thank you.
Yep. And then your other hint is that the vast majority of the time, it's the first atom in the formula that goes in the center as well. So that's your other hint. Okay, so now we have 8 valence electrons in, 2, 4, 6, 8. And then 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. That's the number of electrons, and we can see that currently every atom has an octet. So we don't have to form any double bonds right away. We will only form double bonds that will lead to resonance structures when we do our formal charge analysis. And our formal charge analysis will look at each of these oxygens and say, and since they're all the same currently, they'll all have the same formal charge. Each oxygen has 6 valence electrons, so formal charge on oxygen. And we've done this a couple times before, but it's worth doing again. 6 valence electrons from the periodic table minus 1 bond and 6 unshared electrons. So we get a -1 formal charge. -1, this one's the same, this one's the same, this one's the same, which is a total of -4 so far. We know that that can't be the final answer because we know that the formal charges have to add up to -2. And when we do the formal charge on sulfur, we get 6 valence electrons from the periodic table minus 1, 2, 3, 4 bonds and no lone pairs, no unshared electrons, I mean. So we get a +2. And you can put +2 in your circle now. And that is, now is, we say, okay, sulfur with a positive formal charge. Let's minimize the formal charge by forming not 1, but 2. And you can pick any oxygens here. I just picked those 2. But you need 2 double bonds because each double bond will take away 1 minus charge and 1 of the plus charges here. So our best Lewis structure has 2 double bonds in it to oxygens and 2 single bonds. And since they're Lewis structures, they always have all of the valence electrons, so I better fill them in.
Now sulfur has 12 electrons.
Now sulfur has 12, so not just 10, but 12, which is totally legit because it can have an expanded octet. The most I've ever seen for an expanded octet is 14 on one atom. And that's fine. Doesn't happen that often. We more likely see 10 or 12, but it can be up to, I think of a couple of examples that have up to 14 on the central atom. So this is our best Lewis structure. We can see it has 2 double bonds and 2 single bonds. And when that happens, there are 6 possible resonance structures, which means you have to draw all combinations of single and double bonds. And at this point, I am just going, so you have to draw all the dots, but to show you what they look like, you can take this double bond and leave it in one place and move the other double bond. There's a second resonance structure. A third one would have this double bond rotated up here. And let's see, now the other ones. One of them has that combination, and we'll put a little resonance arrow here, little resonance arrow here. Let's see. There's another one, and there's one more somewhere in here. Double bonds, double bonds, double bonds, double bonds, double bonds. There's the last one. And what I need from you is I need your final answer to have all the electrons around it. But I just wanted to show you there are 6 possible combinations of 2 double bonds. And while we're here, let's do a bond order.
Which one do you use for the bond order? Does it matter? You gotta do them all, right?
You can do them all. You'll see that they're all the same. So I'm just going to pick this one. And there are 6 resonance structures. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9 bonds. So you get 1.5. Not that that was asked for in this question, but it seemed like a useful thing to do. Any questions about this one?
It can be challenging to show all the Lewis dot structures, like to make them look as good as you do. This morning,
No worries, just do your best. And so the main thing, the only things I'm looking for is that it has all the bonds. Those are all the atoms, all the bonds, and all the dots. And as long as I can tell that they're there, I'm happy.
Prof, how did you get the 9?
Good question. I got the 9. So I looked at and just a heads up. So this is the most Lewis resonance structures you'll see on any problem. In fact, all the other ones are less. But so here's how I got the 9. So if I want to do, so this number here is the number of resonance structures. So we know where that came from. Now the 9 bonds comes because I circled the same 2 atoms in all of these. And then I counted up the bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, thank you.
Yep.